So good morning. It is 11 o'clock on Thursday, April the 11th, 2024. I am Jana Hexter, and it's my pleasure to welcome you to the webinar today, Reducing Synthetic Chemical Use to Optimize Pest Management and Crop Production, a case study of onion thrips in onion. And with that, could we move to the next slide, please? The live transcription is available. Oops, Daisy, we want to turn that sound off. Live transcription is available. In fact, let me just turn that sound off so it's not distracting for me. There we go. All right. And so if you like that option, you can select that below. And this is being recorded. And if you're registered for this webinar, I will send you a copy of the recording as soon as it's been edited. And that happens usually in about a week. So probably by the end of next week, that will be done. I'll send it to everyone who's registered. So if you see this webinar and think, oh, I would love my friend to see that, tell them to register and it will go out. And the recording will be up on our website too. And next slide, please. We love having your questions, and there's some really interesting information in this webinar, so I'm sure it will generate your questions. For me to be able to keep track of things, it is much easier if you put the questions in the Q&A feature rather than the chat. You can also ask those anonymously. And if you're not sure about the Q&A feature, if you scroll your mouse over the screen, you'll see that black bar that turns up. And in there, about in the middle, there's something that says Q&A, and there's two rectangles. And if you click on that, you can put in your question. And that helps me if I see 2 or 3 people that have the same question, then I'll make sure to ask that one first. And the next slide, please. It's my delight to introduce our presenter today, who is Dr. Brian Nault. He's a professor and program leader of the Department of Entomology at Cornell Agritech in Geneva, New York. For 25 years, his research and extension program has broadly covered applied insect ecology and vegetable entomology. During this time, Brian and members of his program have focused on understanding the ecology of pests that attack vegetable crops, some of which transmit viruses, and then developing practical, economical, and environmentally responsible IPM strategies. His program at Cornell has helped vegetable growers in New York and beyond successfully implement solutions to their pest problems, including new invasive pests, saving millions of dollars. So welcome, Brian.
Thank you, Jana, for that very nice introduction.
Yeah, so wonderful. I was going to say, it's great to have you here, and this presentation, and you'll see, is very practical and helpful. So before we can begin, we have a couple of questions for you. Yep, then you'll see a poll should pop up on your screen with just 2 questions. So if you could take the time, if you have the capacity to answer those questions, it'll help us know who is here. It'll help Brian see who's here and level of knowledge and interest. All right, so we have 84% participation, so I think we can share those results already. So the vast majority of people are not knowledgeable at all or only somewhat knowledgeable about onion thrip biology. And onion thrip management is the same. We've got over 80% are not knowledgeable or somewhat knowledgeable. So and we have one expert on there. Maybe that was Brian who answered that poll.
No, it wasn't me.
Someone else. So there is another expert here. And great. Okay. So with that, we will move into our presentation. We have a couple of breaks for questions as we go along. So feel free to type your questions in, and we'll get to them when we get to the break sections.
Okay. Let's see. Here we go. All right. Well, again, thank you, Jana, for the introduction. And before I get started, I'd like to just provide a very brief background about Cornell Agritech for those of you who are not familiar with where it is or what we do there. So Cornell Agritech used to be called the New York State Agricultural Experiment Station. And we're located in Geneva, New York, which is about a 50-mile drive north and west of main campus in Ithaca. So we're right in the heart of the Finger Lakes. So at Cornell Agritech, we have members from the departments of entomology, food science, horticulture, plant breeding and genetics, and plant pathology. We also have folks from the New York State IPM program located here, as well as the USDA Plant Genetics Research Unit and the USDA Grape Genetics Research Unit. And the mission at Cornell Agritech is essentially that what we do is take our research discoveries, and whether it's fundamental or applied, and then translate them into practice or practical solutions that will help growers and their businesses thrive. And we generally focus on a lot of different specialty crops, but most of us work with fruit and vegetable crops. And it's this mission that has influenced the goal of my vegetable research entomology program, and that is to solve insect pest problems faced by the vegetable crop industry. And there are three major objectives that I've used to meet this goal. The first of which is just to study the biology and ecology of insect pests, to develop management programs for these pests, and then finally to help growers implement these management programs. So one of the highlights of my research program over the years is the case study that I'm going to talk about today, and that's onion thrips management in onion using fewer chemical inputs, namely insecticides and fertilizer. For those of you who aren't familiar with onion thrips and the pathogens that they transmit to onion, it's a big deal. Annual losses from thrips damage in the United States has been reported as high as $90 million. And insecticide use to manage thrips, not just to control thrips, but also to prevent damaging disease populations of the ones that they transmit, adds another $12.5 million. So it's a lot. So the overview of the outline of my presentation will start out with a brief overview of onion production, onion thrips biology, and its damage. Then I'm going to talk about a couple studies that focus on optimizing onion thrips management using insecticides. Then I'll talk about another study that evaluates a particular cultural control tactic, which is reducing fertilizer, in an attempt to manage thrips. And then I'll finish with some conclusions. So 97% of the onions produced in the northeastern United States are grown in New York State. 60% of the onion acreage is concentrated in central New York in Oswego, Wayne, and Yates counties, and as well as in western New York in Orleans and a little bit of Genesee County. And then 40% is located in the southeastern part of the state in Orange County. Right now, there's about 7,200 acres. New York ranks 8th in acreage in the United States, and the value is just under $50 million per year. Most of the onions are produced in areas that used to be swamps and marshes that were drained over 100 years ago. And here's an aerial photo of the second largest contiguous muck in New York State, called the Elba muck. And in these particular areas, we have muck soils. And these are soils that are very high in organic matter, 20 to 80% organic matter. And they have substantial nutrient availability for plant growth. They're really, really good soils for onion production. Now, one of the challenges of growing onions in these drained swamps is that they're low areas in the landscape, and when we have heavy rains, there can be situations where fields flood like this. However, the growers are prepared for this. They have pumps. They can pump the water out of these fields into canals. And in this particular field that I'm showing you here, within 24 hours, all of the water was gone. With climate change, we also have periods of drought. And since I joined Cornell in 2001, more and more growers are investing in irrigation equipment like you see here. Onions are typically planted in April through the first half of May and harvested anytime between mid-July and the end of September. In between, the crop is intensively managed for insects, pests, diseases, as well as weeds. Onion thrips, Thrips tabaci, is the principal thrip species. In fact, it's the only thrip species that attacks onions in the Northeast. Onion thrips is considered a polyphagous pest, which basically means it has a really wide host range. And it is the major pest of onions worldwide. Here are some photos of thrips on onions. Typically early in the season, you'll find them right around the leaf axil, which is the example of the photo on the left. You'll see them right around that leaf axil. And then as the season progresses, and if control of the population isn't really good, you'll see thrips all across the leaves, and they'll be reach pretty high populations, sometimes well over 1,000 per plant. Now, feeding by adults and larvae on foliage can reduce plant health. And in some situations, this can reduce bulb weights by up to 30 to 60%. The field there, the photo on the left, you can see that the foliage is a little bit lighter colored. Well, that's because the plants basically have very little pigment left in there, very little chlorophyll left in those plants as the thrips have invaded that field. Onion thrips also are vectors of viral, bacterial, and fungal pathogens, and some of the ones are listed there on the right. So iris yellow spot is a particularly devastating disease. It's caused by iris yellow spot virus. The field picture there has essentially 100% infection of iris yellow spot virus. It can kill the onion plant prematurely, like it did in this field. And when that happens, the plants die in an erect position, and they become much more vulnerable to bacterial pathogens. And then you get things like center rot. One of the biological attributes that makes onion thrips such a difficult pest to manage is that it has a very short life cycle. It can complete one generation in about 2 weeks. And that enables this insect to have multiple generations in a crop during the season. We know that onion thrips can overwinter successfully as adults in the soil. They'll generally emerge in late April and May. They'll often colonize other hosts before they then colonize onion fields. So for example, we'll find them in certain weed species along ditches next to onion fields. We'll find them in large quantities in alfalfa and wheat fields, again in proximity to onion fields. And then to a much lesser extent, we'll find them on volunteer onions and also on onions that are imported from the southwestern part of the US that are then transplanted into New York. Onion thrips begin colonizing onions when the plants have around 3 to 4 leaves, and that's going to occur usually sometime in June. And depending on when that crop is harvested, you can have anywhere from 2 to 4 generations completed. Back in the late 1980s, onion thrips was really not on the radar for many growers. It was really easy to control with maybe 1 or 2 applications of a relatively inexpensive pyrethroid insecticide like lambda-cyhalothrin. But then by the late 1990s, growers were using a few more sprays to be able to achieve the same level of control. By the early 2000s, growers were spraying at least once a week, sometimes even more frequently, with lambda-cyhalothrin and sometimes even other insecticides like organophosphates and carbamates. And it got to the level in the early 2000s where there's a crisis. The growers could not manage this pest with the insecticides that were labeled. And we did determine that the reason for this was indeed insecticide resistance. As you can imagine, with selection pressure with that many sprays with one particular product, that you're going to select the populations of thrips to become resistant. And that's what was happening. So like I said, I arrived in 2001 right in the heart of this problem, and growers needed a solution immediately. So what were the different options? Well, there weren't many. In terms of plant resistance, there were no varieties that were resistant to thrips. In terms of biological control, the natural enemies that were in fields weren't doing enough to regulate the populations. There weren't enough cultural control tactics that were examined that we could really use. So basically, that left us with chemical control, the one tool that growers were not able to use successfully. Okay, so that finishes the background, and now I'm going to launch into the first series of research studies that were designed to optimize onion thrips management and also to come up with strategies to mitigate resistance development. So the approach was to first to identify insecticides that would work and then assist in their registration. The second was to develop an insecticide-based program that optimizes insecticide use by keeping an eye on trying to develop a strategy that would avoid resistance development or at least delay it. And then finally, to help growers implement this program and measure its success. In 2005, the IR4 program supported research to identify products that would work in onions for managing thrips. And there were a long list of products. I'm not going to show you all of them, but the most important thing is there were 3 products that we found that did work. Agrimec, which is abamectin, Carzol, which is formetinate hydrochloride, and Spintor, which is spinosad. So we're able to work with EPA and also work with our at New York State DC to get Section 18s for these products. And this basically avoided the crisis that the growers were having. They had tools to use that were effective in managing thrips. Of those 3 products, there's only one that is currently labeled today on onion, and that's Agrimec. They're at the top of the list. There are a bunch of other products that you can see here that have been labeled since that time. And the main purpose of me showing this slide is really to focus on this middle column, this IRAC class. This is basically different classifications of active ingredients. And what you see here is that of the products that are currently labeled for use on onion to manage thrips, we have representatives of 6 different IRAC classes. This one here that is checkered, that's actually a blend of 2 of the existing classes that are on this list. But anyway, so this is really important because without having different classes of chemistry, we wouldn't be able to develop a program that would ideally mitigate resistance development to any one of these particular products. So as I've mentioned, a thrips management program using insecticides needs to be very strategic, and it needs to be based on insecticide resistance management principles. And here are 4 principles that were used in the program that I'm going to discuss in a minute. One is to limit the use of each insecticide class to no more than 2 applications per crop per season, and to use them sequentially, back to back. And then to rotate these classes through the season. I'll show you an example in a minute. And then next, to develop action thresholds so that applications would be made only when needed. And then finally, combine with non-chemical management tactics. So here's one of the early examples of a sequence of effective insecticides that were used to manage thrips. So you can see 4 different products, each belonging to a unique class of chemistry and class, and no more than 2 applications made. And the idea here is that you would limit exposure of one product to more than 1 generation, or at least as best one could, which is very important for reducing selection pressure. What we found was that this particular program was really effective. You say, why is that a problem? Well, growers were basically spraying on a weekly basis still. And some of these products had much longer residual activity than 7 days, and we felt like they didn't need to spray on a weekly basis. So it was time to develop action thresholds. So we had kind of a baseline for what a good economic injury level was, and that was 2.2 thrips larvae per leaf, averaged over across the entire season. So we started looking at action thresholds for some of the commonly used insecticides, and basically what we found was 1 thrips per leaf was most preferred. So once that density was met, we sprayed, and that kept that population from exceeding that economic injury level. So the idea here is that we combine this great sequence of products that I had done a lot of research to find out which really fits in best from the beginning to the end of the season. but then overlay action thresholds so that if one insecticide like Movento was so effective that a week after that second application, the population was below 1 thrips per leaf, you could skip a spray. And in fact, maybe you could skip using an entire product or use a product like Exirel only one time instead of twice. So that was the idea. And now we wanted to test it. So we did so in small plots in commercial onion fields. So the objective was to compare thrips control and marketable bulb yield using an action threshold-based program compared with the standard weekly spray program. And the hypothesis was that thrips control and marketable yield in onions treated following the threshold program would be the same as following the weekly program. I recruited Ashley Leach as a graduate student into my program. Ashley currently is an assistant professor in the Department of Entomology at Ohio State. And Ashley's one of her main chapters in her PhD thesis was to look at this question or examine this question. So compare the action threshold versus the weekly. And basically, the program was like you see here, starting with Movento and moving through to Exirel. And then overlaying the threshold here on the left, that program only spraying if that population was above 1 or equal to or above 1 thrips per leaf. So Ashley conducted this experiment on 3 different cultivars, Avalon, Delgado, and Bradley, over 2 years. And to assess the efficacy of the treatments, we recorded the numbers of onion thrips on onion leaves or onion plants visually, like you see here. And the dependent variable was the season mean number of thrips larvae per leaf. We did this on a weekly basis. I'm not sure if I said that. We also wanted to see how the impact of these particular treatments impacted bulb yield. So we measured bulb size, graded them into different classes, and then weighed them. All right, I'm now going to talk about the results, focusing on thrips densities. So on the y-axis here, we have the mean season number of larvae per leaf, and then the different insecticide programs, either the untreated control, AT, that's for action threshold, and standard, that would be the weekly treatment for the 3 varieties, Avalon, Delgado, and Bradley. And then this dashed red line here is the economic injury level of 2.2 thrips per leaf. So essentially, we would want our insecticide programs to have densities of thrips that would be below that dashed line. So first, I'm going to show you the levels in the untreated control. So all of the mean larval densities were above this dashed line, which basically tells you that we had an economically damaging population of onion thrips in this study, which is what we wanted to really be able to test our treatments under higher pressure. That was true for all 3 varieties. And then if we look at the mean season number of thrips larvae in our action threshold and standard treatments, we see no significant difference in all 3 varieties, which is, again, what we thought would happen. That was in 2015. And if we look at 2016, we essentially see identical results. The thrips pressure wasn't quite as high in 2016, but again, the action threshold program provided a significant level of control and equivalent to the standard program, with exception in Bradley, where we see that the action threshold treatment wasn't quite as good as the standard, but that level was below that dashed red line, suggesting that it was unlikely that this would have any economic impact on yield. So what about the number of sprays between the 2 treatments? So on the far left, you have the cultivars, then you have the year, and then in the middle, there's the standard number of weekly applications. So in 2015, there were 7 applications made over the course of the season. In 2016, it was 6 sprays. Using the action threshold-based applications, we average far fewer. On average, between 33 and 50% fewer numbers of applications using that threshold system. All right, that's great, but what about yield? So here we have the mean marketable yield represented in metric tons per hectare for all of the treatments for the 3 varieties, and this is in 2015. So what you wanted to see were no statistical differences between our action threshold and standard treatments for all 3 varieties, and that's exactly what we saw. In terms of the untreated control, we see that in Bradley and Delgado, we had significantly lower levels of marketable yield, which we suspect because those populations were above that economic injury level. But for Avalon, we did not see that. And this is interesting. Avalon was touted as having some thrips resistant properties. It had low levels of wax and low levels of this particular H16 ketone that we know was important in thrips resistance. So that's why we didn't see that lower level. On a side note, unfortunately, Avalon is also highly susceptible to stem filling leaf blight and bacterial bulb rots, at least in our very humid climate. So unfortunately, it's not a variety that is going to be able to be grown economically in the Northeast. Okay, and then in 2016, essentially we see the same results. But in this particular year, we do see a significant reduction in Avalon yield in that untreated control. But again, the threshold worked beautifully. So our hypothesis was that thrips control at a marketable yield in onions treated following the threshold program would be the same as those in the standard program, and that's exactly what we saw. So that was all fine and dandy in our small plot research trials on the commercial farms. But now we are ready to scale it up and have onion growers actually implement this on their farms. As I showed you, our onion thrips management guidelines started like this. We call this version 1.0, where basically there are 4 products and you use them in the sequence, overlay your action thresholds on that, all fine and dandy. Now I want to show you what it looks like today. As more insecticide products become available. 2, as some growers are more comfortable using some products than others. Some products are more expensive than others. Anyways, sometimes onion thrips pressure is higher at different times than others, that we've come up with this particular plan, and it works out really well. It just gives growers much more flexibility and following the path that they want to. But all of them start with Movento, and then after that, you can take a number of different trajectories. No more than 8 applications within a season, usually far less than that in most places. Sometimes only 2 to 3 sprays are needed. So the objective of this particular research project was to evaluate onion grower adoption of these guidelines, essentially focusing on how many rotate their insecticides and how many use action thresholds. And our hypothesis was that onion growers will increase both. So to do this, Ashley Leach was in my program at the time, and we reeled in Christy Hopeteen, who is a Cornell Cooperative Extension educator with a Cornell vegetable program. And Christy has a very successful program working with onion growers in Central and Western New York. And essentially, Christy, Ashley, and then 2 other Cornell Cooperative Extension assistants worked with growers to help them adopt this. And we identified 17 growers. That's what this N equals 17 is. So we had 17 growers that agreed to participate in this program across the state. And before we started, we wanted to get some baseline data. The first was how many of the growers were making insecticide applications and rotating those classes of insecticides. And already 3/4 were doing so. And some of that was easy because on the label of the products, it says you can't use it more than twice and you have to use it back to back. Nonetheless, it wasn't 100%. Only a little above half of the growers were actually using action thresholds. And most of these growers were still spraying 1 time per week, despite the fact that some of these products were really, really effective. So basically 3 to 5 growers were identified in each of these particular counties in New York and agreed to work with us and over a 3-year period. And essentially what we did was we scouted their onion fields for thrips on a weekly basis, and we provided them with the results every week. And we basically said, look, If the population is above the 1 thrips per leaf threshold, then you need to spray and spray with a product based on the guidelines that I just showed you. If the population was below that threshold, the recommendation was just skip a week. You don't need to spray. And the program was quite successful. So after the 3 years, we conducted the same survey, and now all of the growers, all 17, were successfully rotating those products or following the sequence. 82% were using thresholds, and the growers were making 2 to 4 fewer insecticide applications per season compared to what they had been doing. And they were saving, on average, about $60 per acre. So the hypothesis was the growers would increase their adoption of this plan, and indeed they did. So onion growers from the Elba Muck were honored with the 2019 New York State IPM Award, primarily for their adoption of this thrips management plan. And we asked them, so why did you do it? And the number one reason was that they were terrified of insecticide resistance. So they did it because we told them that this should slow down the evolution of resistance. And it was not due to saving money. Of course, that was a nice benefit, but that wasn't one of the major reasons. And the other reason was they really enjoyed the regular interactive meetings that we had with them. And that built trust between the scout and the grower, and that was really important. And then finally, as of today, we have no conclusive evidence that there's resistance to in thrips populations to any of these newer products. So at this point, I guess we're going to take a quick pause and see if there are any questions, either in chat or however else we
coming
address
through.
this.
Okay. Yeah, we just have one question, although somebody may be typing as we speak. Do the onion growers typically do crop rotations? And do you think crop rotations would reduce onion thrips?
Excellent question. So I would say that a majority of, maybe about half of the onion growers don't rotate any of their fields. So it's basically onions grown behind onions. The other half do rotate, but oftentimes the rotation may be a very, very short distance. For example, maybe just one of their fields within the muck, they'll take out of onion production and put in soybean or something like that. So oftentimes the rotation isn't real far. I think overall that regardless of that particular point, which is really important, don't get me wrong, crop rotation is really important. It's much more important for pests like onion maggot than onion thrips. But because onion thrips oftentimes are coming in from these other crops, that rotating their crop, you're not going to be able to get far enough away from, say, alfalfa or small grains, where we think a lot of onion thrips are coming from. We also know that onion thrips are common in weeds along ditch banks, and they're going to be pretty much everywhere, every ditch bank. So I just don't think that crop rotation is going to be a very effective strategy to manage this particular pest. But it's really important for a lot of other reasons. Like I said, for onion maggot, for soil health, for soil pathogens, and that kind of thing.
Okay. All right. And we actually have another question about crop rotation, but I think we're going to leave that until we've gone through the rest of the presentation, and we can circle back around to it and any other questions that come in. So feel free, folks, to add your questions, because we will be answering some more at the end.
Sounds good. Okay. So we learned that we were able to optimize the use of insecticides to manage thrips. So that was a success. But we really need other tactics, especially non-chemical tactics. And are always looking for different slants on how to do that. And one group that I belong to is a multi-state group. And this group consists of other academics like myself, a lot of different disciplines, not just entomology, but plant pathology, weed science, agronomy, and onion growers, cooperative extension educators, folks in the industry, including onion breeders. Anyway, we have these meetings once a year, and in one of those meetings, some of the growers that attended were from Utah, and they claimed that they didn't have to use insecticides to control thrips anymore. And of course, every head in the room turned around to look at them, and they said, yeah, they reduced the amount of fertilizer, in particular nitrogen, that they used on their crop. And once they did that, they didn't have thrips problems, and they were still able to maintain pretty decent yields. Well, that particular comment resonated with a number of us, and there were some folks from Utah State that examined this idea and compared onion thrips adult and larval populations in onions that were grown under standard fertilizer practices, as well as those with reduced rates. And indeed, they saw a significant reduction in both. So certainly I thought, well, maybe that could be a particular tactic that would work in New York State. So now I'm going to talk about the research that we did on examining the reduction of fertilizer as a potential for reducing thrips populations and their damage in onions. So the approach that was taken was to identify the impact of reducing fertilizer on onion thrips populations as well as bulb yield, to determine the optimal amount of fertilizer that will reduce thrips populations but not bulb yield, and then finally to implement fertilizer reduction and measure its success. Right now, the onion fertility guidelines are as such. For nitrogen, 100 to 125 pounds per acre. For phosphorus and potassium, 50 to 150 pounds per acre. And then a lot of the growers use a custom blended fertilizer mix, and I've included some of the ingredients here. I don't want to have to go through them right now, but for the main source of nitrogen is urea. So the objective was to compare thrips densities and marketable bulb yield using reduced rates of fertilizer compared with a standard fertilizer program. And the hypothesis was that thrips densities in onions grown using the reduced rates would be lower than those using the standard program without a reduction in yield. So for this study, I recruited Carly Regan into my program. Carly had just finished her PhD in the Department of Entomology at Penn State. And currently, Carly is a product development manager with Certis. And Carly worked with a handful of growers and 20 different commercial onion fields over a 3-year period from 2019 through 2021 in Central and Western New York. And here's an example of one of our trials. So we selected an onion field, and the width of our experiment was at least 30 feet. It was basically as wide as the fertilizer spreader, and the plots were each 150 feet long. So all total, it was 450 feet. And then we randomly assigned one of 3 treatments to those blocks. Either no fertilizer at planting, a full rate of fertilizer per planting, what the grower typically would do in that field, and then half of that rate. And on the far left, we see the mean amounts of NPK for each of the 3 treatments across all of the fields that we worked with over that 3-year period. So just looking here at the full rate, the growers averaged 112 pounds of either nitrogen or phosphorus per acre, or 196 pounds of potassium per acre, which is above what's recommended. But at any rate, that's what we had. And then at 2 time points during the season, we took soil samples to verify that we did actually have higher levels of NPK where fertilizer was applied compared where it wasn't applied. And indeed, that was the case. So the growers did well. Okay, so to evaluate the treatments, we recorded thrips densities in the fields on a weekly basis, just like I described in the previous study. And at the end of the season, we sampled small areas of onions. We brought them back to Geneva. We graded them into different size classes and then weighed those size classes. And now I'm going to show you the impact the fertilizer treatments had on onion thrips densities. So on the y-axis, we have the season mean number of thrips larvae per plant for the 3 different years. And then either no fertilizer, half rate, or full rate. And here's what we found. Swing and a miss. We found absolutely no impact of reducing fertilizer on onion thrips populations. And of course, we looked, at different times of the season and these types of things. Basically, we just didn't see any impact at all. So it just did not work in New York on our muck soils. So our hypothesis was that reducing fertilizer to reduce thrips populations would be a great non-chemical control tactic of thrips. Didn't work. So then we still had all this yield data to look at. So we wanted to see how the impact of reducing fertilizer impacted marketable yield. And essentially, we didn't see any differences in the different size classes of jumbo and standard size onions. So we pulled all that data together for marketable yield and basically looked at it the same way. And in 2019, we were pretty amazed at what we found. Or maybe we thought we did something wrong, because the plots that had 0 fertilizer applied at planting had yields that were equivalent to those that had either half or full rate. It's like, uh-oh, we did something wrong. Well, we got to do it again. So we did, and guess what? The same exact results. There is no impact whatsoever of fertilizer on our onion yields. Well, this is quite amazing. And we had a twilight meeting where we invited growers from Central and Western New York to come actually to see one of these plots, one of these demonstration. Well, we call it a demonstration trial, but it was actually one of the experiments in one of the growers' fields. And we had the growers and folks in industry, the fertilizer folks, they came out into the field, and we asked them which plot received no fertilizer and which plot received half or full rates. And guess what? They couldn't do it. You couldn't look at the plants and tell at all. In fact, the grower whose field this was in also was just scratching his head. He was amazed that there was no difference. And we saw this year after year after year. So why did this happen? This seems wrong, right? Well, I attribute the lack of any impact on the fact that we're growing our onions in muck soils, which are high in organic matter. There's substantial nutrient availability already for plant growth. Now, I'm not going to certainly recommend that growers stop using fertilizer, but certainly they can cut back, and maybe even or cut back not even on a yearly basis, but they could certainly reduce what levels they're currently using. So that was basically the next step. And here, basically, I passed on the baton to Christy to work with growers to have them implement a reduction in their fertilizer use. And over the last several years, the timing's perfect for this. Why? Because fertilizer prices have been on the higher side, and growers are looking for ways to cut back on their expenses. So Christy worked with some growers on this project. And essentially, this is what we found. And here is just the amount of nitrogen fertilizer that 4 different growers reduced on their farm. So the farms here, Elba, New York, Wayne County, and a couple in Oswego County. And before the project, this is the amount of nitrogen that they were using per acre. And here's what they're using now. So basically, between a 22 and a 57% reduction in the amount of nitrogen fertilizer anyway that the growers are using. And they've had no indication that they're sacrificing bulb yield or size based on these reductions. So I talked with one of the growers in Western New York. This is a grower from Big O Farms, and this is the largest farm in New York in terms of onion production. They grow 2,150 acres of onions. So that's 29% of the total acreage in New York State. That's pretty remarkable. And the growers growing the same number of onions, or excuse me, the same acreage of onions now as before this project was conducted. And before the project, basically the grower is putting down 1,000 pounds per acre. After this project, and I'm not saying this is 100% due to our study, but certainly I believe it influenced this decision. But now is using 350 to 400 pounds of fertilizer per acre on transplanted onions, 750 to 800 pounds of fertilizer on seeded onions. And that's a 44 to a 49% reduction in fertilizer. That's incredible. Basically, in terms of what that means in terms of pounds per year, it's either a little under or a little over 1 million pounds of fertilizer per year just on this farm. And based on the cost of, I think last fall I used 44 cents per pound of fertilizer. That would be a savings in $420,000 to $470,000 per year. And this, again, this is just one farm, granted being the largest farm, but that's quite a remarkable savings. So reducing fertilizer as a tactic to potentially reduce thrips populations failed as a control tactic. However, it was successful as a new onion production tactic, if you will. It reduced costs, it increased profits, there's less pollution in the environment because there's less fertilizer being used, and certainly decreasing labor and carbon emissions. So just to wrap things up, onion thrips management is still heavily reliant on insecticide use. Other tactics have just not been promising, and I could give another seminar on all the tactics looking at plant resistance and biocontrol and cultural control, but unfortunately none of those tactics are very effective at all. But both insecticide and fertilizer inputs can be reduced substantially without negatively impacting onion yield. That's definitely a positive out of this. So I'd like to acknowledge a number of folks, beginning with Christy Hopeting with Cornell Cooperative Extension, former PhD student Ashley Leach, former postdoc Carly Regan for spearheading the major studies that I've talked about today, Steve Reiners, who is a professor in the Department of Horticulture, who helped us with a lot of the fertility questions, Tony Shelton, who is now an emeritus member of our department in entomology, and many, many research assistants and technicians over the years. And then a number of onion growers who allowed us to do this research on their farms, very, very appreciative. And then a number of funding sources, both federal, state, and grower oriented. So with that, I would be happy to entertain any questions that you all may have.
Great. I was going to say it was very interesting. So we have a couple of questions, particularly about this study, and then we'll go back to the resistance question. So did you use any chemical insecticides in any of the plots in the fertilizer study?
Yes. All right. So in that particular study, I only showed you part of it. So just for the sense of telling this story, I just focused on the fertilizer component. But essentially what we had was we overlaid an action threshold based insecticide program on the trial. And then within that, we also had a weekly spray program. So yes, thrips were managed in those particular plots based on what the growers program had. That's correct. So it wasn't like we had untreated plots to really examine the different fertilizer treatments.
Great. Kimberly Littleton said, I'm curious if any growers are tracking their OM totals over time. Have totals started dropping yet?
Okay, I missed what totals?
OM, it looks like.
Oh, organic matter. Okay, yes, yeah. So, see, I'm an entomologist. I don't know very much about soil fertility, maybe just enough to get myself in trouble. But I do know that growers do consistently, do the soil nutrient, soil testing on a yearly basis and that type of thing. And whether or not organic matter is included in those soil tests, I'm not 100% sure. But my guess is to some extent they are monitoring that. Certainly organic matter and these muck soils are a finite resource, and they're being reduced yearly based on oxidation of the soils, wind erosion and that type of thing. And I know growers are trying to use more cover cropping to try to get organic matter back into the soils. I don't know how successful that is. Certainly it doesn't hurt, but in terms of what organic matter levels are through time, I really don't know that, and that answer to that question. It's a really good one though.
Yeah, I was going to say we had a similar question as if fertilizer inputs are reduced, will the muck soils eventually be depleted of nutrients? So it's a similar question. Clayton Myers said, does pest pressure preclude organic production in New York State, or are they able to put together a program with spinosad, pyganic, and excuse my pronunciation, and other biologicals?
Yes. Hi, Clayton. No, good question. We do have organically grown onions in New York State. They tend not to be on these muck soils. I can only think of, golly, maybe one example where that we may have some organic production on these big muck soils. The organic onion production tends to be on mineral soils, on small diversified farms, generally speaking. So it'd be a much smaller area. But nonetheless, thrips arrive. Sometimes I've never seen them in pressure levels like I see in these larger areas of muck, but we do get onion thrips. And indeed, they are managed with the products that Clayton just mentioned. By far, spinosad or Entrust is much more effective than the others that were mentioned. The others might provide a little bit of control, but really Entrust or spinosad is the main driver of that. I conducted a series of studies looking at a combination of OMRI approved products. These are products that are allowable in organic production, along with a new onion thrips resistant variety, and also using reflective mulches, because a lot of our organic onion production occurs on these smaller farms, and they use reflective mulch with drip irrigation and that type of thing. And essentially what we found was that the reflective mulch, maybe one year it might reduce thrips a little bit, another year not at all. The resistant variety that we looked at, Rosa del Milano, again, once in a while you might see a slight reduction in thrips, but another year not at all. But the one factor that was consistent in reducing thrips was Entrust. But unfortunately, you can only use it, or should only use it, twice in the season. And as you know, sometimes we have 6 to 8 weeks of time where we have to protect the crop. And when you only have 2 applications of Entrust to use, and it needs to be back to back, that really makes you vulnerable for a large part of the season. So it's still really challenging. I will say real quick before we move on to the next question, that what I advise growers who are growing onions organically to do is to shorten the period of the season where thrips are going to actually attack the crop. And to do that, number one is transplanting them, because that gives the crop a head start, and then to use an early maturing variety. So that way you transplant it and it matures quickly, so you can harvest it more after a very brief period. And then those 2 applications of Entrust can provide you a much greater period of protection of that crop. So at any rate, I think by using all of those tools, organic production of onions has been relatively successful.
Okay, great. So, and this one last question, which you may kind of have talked a little bit about, but maybe there's something to add. Is there any work done on organic farms with thresholds versus conventional spray schedule?
Yep, absolutely. We have looked at that question on a couple organic farms near Geneva, and then also we had some of that study done on our research farms here in Geneva. Yeah, and essentially what we find is that 1 thrips per leaf still seems to be a pretty good threshold. And again, with a product like Entrust that works really well, that threshold seems to hold very well. So that 1 thrips per leaf for Entrust seems to work out pretty well. Yeah.
Okay, great. And how far can thrips travel, and should management practices be adopted at a regional scale rather than a farm scale?
Yeah, really good question. Yeah, we've done quite a bit of work looking at thrips dispersal. We know that they can disperse very long distances. We've actually used remote control airplanes to basically capture what we find 100 feet up over the onion fields. And indeed, we can catch onion thrips, and some of them carrying the virus, Irish yellow spot virus. So we know they can move very, very far distances. A majority of the populations, however, tend to move, at least in the onion production system, from field to field. That's the preferred, well, or at least a majority of the population is moving relatively short distances. So once, say, a mature onion field or an onion field matures, the leaves begin to lodge some, you'll see thrips then move from that field to the nearest less mature field, if you will. So we know that that's the general level of movement. So for management strategies, we definitely need to consider more of a local scale in our determination of management. But because we do know they can travel longer distances, and I suspect they do move from alfalfa and small grains, and a lot of those fields aren't right next to onions. They may be a half a mile, 5 miles away. And we are pretty sure that they do arrive in onion fields. That in terms of an area-wide strategy, it's not a bad idea in terms of what maybe overall products might be used. But because of different growers farming in the same areas and different pest pressures in transplanted onions and direct seeded fields, maturity differs, it becomes I would say extremely challenging to do kind of an area wide where, say, all growers can only use one product in the month of June and maybe another product or chemistry in the month of July. I think that would be much too difficult to pull off.
Yep. All right, wonderful. And there is a very interesting question and comment from Susan Beale, but she also said she'd be happy to ask the question of you via email. And given
Absolutely.
the time, I would suggest that we move on. And thank you for all your wonderful questions. So if we can move to the next slide, that would be great. All right, we have poll questions. There are 4, and I'll be quiet while those are answered. Okay, and I'm going to share the results, which are actually very interesting. So we've moved the needle there. A lot more people are moderately, somewhat, and very knowledgeable about the biology of onion thrips, and the same as far as onion thrip management. That also has moved the needle there of our participants. 100% of people said that they would consider reducing the amount of fertilizer they use in the vegetable crop production as a result. And this is also music to our ears, that as a result of this webinar, the majority of people, over 80% almost, are very likely or extremely likely to consider using IPM or increase their implementation of IPM. So thank you very much for taking the time to answer that poll. And we have a couple of little things before we end. So one is, next slide, please. And I believe that is a reminder of the recording. Oh, upcoming webinars. We will be picking up and doing more webinars in the fall. We try to do them when outside of planting season and crop season. So to have a look out in September, October, November, you'll see more webinars, and and you'll hear about that as having registered for this webinar. And next slide, please. If you would like to connect with colleagues who are also interested in vegetable production and onion production, we have a capacity on our website where you can go and put a profile about yourself, and you can also take a look at the profiles that have already been put up. So, for example, if Dr. Nault was looking for onion growers to work with on a study, and you are an avid and enthusiastic onion grower that he may not have come into contact with yet, you could put a profile about yourself, or also find other researchers who are doing work that may be of interest to you. Next slide, please. The recording will be sent to you in about a week and will be available on our website in the future, so you can watch it as many times as you would like. Next slide, please. The Northeastern IPM Center is based at Cornell University in Ithaca, New York. Cornell University is located on the traditional homelands of the Gayakono, the Cayuga Nation. The Gayakono are members of the Haudenosaunee Confederacy, an alliance of 6 sovereign nations with a historic and contemporary presence on this land. The Confederacy precedes the establishment of Cornell University, New York State, and the United States of America. We acknowledge the painful history of the Gayakono dispossession and honor the ongoing connection of the Gayakono people, past and present, to these lands and waters. This acknowledgement has been reviewed and approved by the traditional Gayakono leadership. And lastly, we would like to acknowledge, next slide, please, our funders. This webinar series is provided through funding from USDA NIFR, and we're extremely grateful for it. So if you have not filed your taxes yet and are going to do so this weekend, you can think of this webinar as you do that. So, so thank you all for your great questions and your attentiveness, and it was a very interesting presentation for me. I'll be thinking about this so much more as I eat my organic onions this summer. So thank you, Dr. Nault, for this fantastic presentation and all the research that's behind it, and all of the years of expertise and hours of study that has made it possible for you to do this work. So thank you very much.
Thank you.
Right. Okay. And with that, goodbye, everybody.